Hello and welcome back to our channel. In today's video we will see what is NMR spectroscopy, and in today's video we'll see the introduction of NMR spectroscopy, and then in the later videos we'll see how to solve the questions regarding NMR spectroscopy. We will solve different examples inshallah. And we'll see how to solve the combined examples of NMR spectroscopy, including IR spectroscopy, mass spectroscopy, UV spectroscopy, Hmqc NMR spectroscopy, Hmbc NMR spectroscopy, hydrogen Cosy, and all of the related NMR spectroscopy techniques. So firstly, let us start with the introduction of NMR spectroscopy. Basically, NMR spectroscopy means nuclear magnetic resonance spectroscopy. NMR stands for nuclear magnetic resonance spectroscopy. So in NMR spectroscopy, we basically see different signals. The graph is usually plotted like a signal here, here, here. So this is the graph having ppm values here, and it will start from 0 to 14. It will start from 0 to 14 and it will be considered as the ppm values. So from 0 it will be 1, 2, 3 and up till 14. So these are called as the ppm values. As we are seeing the introduction of NMR spectroscopy, so let us first explain how we can predict the compound by seeing this kind of spectra, this kind of the graph. From this we can make the compound. We could suggest what the compound could be and how to solve the problem. So let us first see the basic introduction. So I'm going to tell you the basic introduction, and then inshallah ta'ala in the next videos we'll be able to see how to solve NMR problems. So firstly, let us see the basic intro. So let me solve here. This is the basic. This will be the graph from 0 to 14, and this will be ppm values. Okay, here it will be like this, and the graph will be plotted here. The graph will be plotted here like this. A line would be here, a line could be here, a line could be here, a line could be this kind of graph you can see in NMR spectroscopy. So how could we predict what would be the compound after seeing either this kind of graph or this kind of graph? Here you can see the graph is in the form of the straight lines because we have not seen the multiplicity here. It is shown in the form of single lines, but here it is more accurate because here we could see the multiplicity. As this you could see, it is the singlet, it is a singlet, it is a doublet, because we are having two of the lines here, two of the peaks here, and this 1, 2, 3, 4, and this will be a kind of a thing having such number of peaks. So let us now move towards the ppm values. What will be the ppm value of which of the compound? So let me tell you how to solve an NMR problem. So this is basically the intro. Let us see what ppm values tell us. So the first peak, which is at 0 ppm, is the value of TMS. TMS is tetramethylene methylsilane. It is the starting, we could say it is a material whose peak you are seeing here. It has it is of no use in our spectra, in our whole calculations. It will be present here, and you have to do nothing regarding this. It will be here. So this peak at the 0 ppm is none of your concern. So 0 ppm is of TMS. TMS. So you will not consider anything at 0 ppm. Whenever there is a peak at 0 ppm, you will neglect it as if it is not present here. The point is, I think the point is clear here. Then we'll move towards the next points. We'll see at which ppm which of the peak is coming and what does the peak predict us. The second thing which I want to clear is, first of the peak which you have to neglect is at 0 ppm, because it is not of your use, so you will neglect this peak. Then at almost, whenever you are seeing carbon 13 NMR, at that time you will be having different values of the ppm here, which will start from 0 to about 200 or 220 ppm. So the peak which will be present at 80, it will be the peak of the solvent. It will be present in the form of 3 lines. So you have to neglect that 3 lines. The peak, this peak is of the solvent, so it is also not of your use. So you will have to consider it as if it is nothing. So from here we have seen 2 of the important things. This is basically the intro for all those chemists, for all those students who are very new to NMR spectroscopy or to spectroscopy even. So this is the basic intro, and then we'll move towards the more advanced techniques in the next videos, inshallah. So in carbon 13 NMR spectroscopy, the peaks which are present at 80 ppm will not be of your concern. These will be the peaks of the solid